What is the volume of the solid formed by revolving about the x-axis, the region in the first quadrant of the xy plane bounded by the coordinate axes, and the graph of the function y is equal to 1 over root 1 plus x squared? Okay, so this is probably a fairly, this looks like a fairly typical volume of revolution type question. So I think the first thing we might do is just plot this function, get an idea of what it looks like. So we're only concerned with the first quadrant, as it says, and we want it's being revolved around the x-axis. So when x is equal to 0, this function is equal to 1, and it clearly just sort of decays like that in some way. I'm not terribly concerned with the exact shape, but what I do notice is that the integral that we're going to have to evaluate to do this is going to be, it's going to have bounds from 0 all the way to infinity, because the function never actually hits 0. Okay. I never remember exactly what the formula is, but we're revolving around the x-axis, and so I want to think of this as being a radial slice of a disk. So the volume is going to be the integral from 0 to infinity. So this is like the radius of a disk as a function of x. The area of that disk is pi r squared. Okay, and of course the radius is the value of the function, so we have pi times that function at the top all squared. Okay, and this is, I think this is some kind of trig integral. Probably something like tan inverse. Let's derive something. Okay, so I have tan squared plus 1 is secant squared. If I say y is equal to, sorry, if I say x is equal to tan y, then 1 is equal to secant squared y prime. So y prime is 1 over secant squared y is equal to 1 over 1 plus tan squared y, and y is 1 over 1 plus x squared. Yeah, so it's tan inverse of x right. I've shown that if y is equal to tan inverse x, then the derivative, y prime is 1 over 1 plus x squared. Okay, so tan inverse x evaluated at 0 and infinity. Tan inverse of infinity is pi over 2. And tan inverse of 0 is 0. So I get pi squared over 2 as the volume. And let's make sure that this is one of the options that's given. It is. This is option D. Yeah. So a couple different things coming together in this problem. Knowing how to compute volume of revolution. I never remember this formula, but it's really, really easy conceptually to derive, right? Imagine this whole function is being revolved around the x-axis like that. Then if you take a slice, it's going to form a disk, and that will be the radius of the disk. So pi r squared, That's the area of that disk multiplied by the thickness dx and integrated out. And then, of course, someone who was actually writing this test for real, I would assume that a lot of these specific antiderivatives would be fresh in your mind. My instinct was telling me there was something trigonometric going on here, but I wasn't completely sure which one. But that's a good first guess for something like that. If that didn't work, I would have just guessed another inverse trig function and made sure that I had the correct antiderivative. There's the answer, pi squared over 2. Thanks for watching.